starting the recorder right now. All right, so we can, okay, let me go back to the assembly code here. All right, I will, okay, wait, it's my cursor, there we go. No, I just want to close that window. There we go. So given the assembly code, okay, how do you reverse it back to C code? That is the question. So the first thing is, if I give you something like this, PTR, count, local var length, and then the argument, and the code is known to be correct, that will give you an idea of how the frame is set up, which also it will tell you what is on the stack. Okay, do you have parameters? Do you have local variables? How many local variables? How big is a local variable? That will give you that idea. Now, it doesn't tell you the types, right? It doesn't give you the type information of whether PTR is a unsigned character, is it a signed character, or is it a pointer. You won't know. The name does kind of imply that it's a pointer, but if I use a very generic name like X, Y, Z, and so on, then you wouldn't be able to tell from the name itself. So now you have to look at how the value is being used. So to reverse the process, you really have to figure out what is in the register, because by this time you should know that register A has the address of count, and we are just storing a 0 into count. So it's really just the reverse of the whole process. Okay, you figure out what we are doing with items on the stack, and then you basically go like, oh, okay, this is equivalent to count equals to 0 in C. Now, you still have no idea whether count is signed, whether it's unsigned, or whether it's a pointer. You have no idea. All right? So if we start to use the value of count and start to dereference it, then you know it is a pointer. Okay? So that is things that you have to be able to infer by whether the value of something on the frame is dereferenced or not. Okay? There's some text activity. Are we supposed to be able to see something right now? Yes, I have been live streaming. I think it's still active. So if you, oh, wait. Am I screen sharing? I think I'm screen sharing. I can see my screen here. I'm not in Google Meet. Google Meet is is idling. It's in Discord. So go to the Discord side. I'm just gonna end the call on Google Meet, so people don't try to follow that one. I'm gonna end the entire call, so no one is gonna stay on the other side. There we go. There we go. So I think everyone should be now on Discord. It's also being recorded. This portion is being recorded right now. All right, so now, we look at the next few statements and try to figure out what it does, right? So by this time, we have PC in register, the address of PC. This is the value of PC. And AA is very indicative of we just want to know one or the other, okay? Because it can be one or the other. We may want to know whether it is 0 or not. That's the Z flag. But sometimes we also want to know whether the sign flag is a 1 or not. Okay, so this is a very kind of cool shortcut. So which one it is depends on the flag that we check right after the AND operation. Because the AND operation, if you look at the ALU, really only the sign flag and the Z flag are properly refreshed. The other ones are just going to be either the same as before, or they're not useful. So only the Z or the S flag are useful, and this time we're using the Z flag, which means we're checking whether something is 0 or not. If so, we get to a certain label. And then the more difficult stuff to figure out will be something like this, because register A. So this is why it is important to keep track of what is in the register, because at this point, if you don't know that register A already has the address of a structure, then it becomes very difficult to figure out what these few instructions are doing. So understanding that register A has the address of the beginning of a structure, and we're adding the offset to a member of the structure to the beginning address of the structure means that we are computing the address of a member of a structure, And then by dereferencing it, now we're getting to the value of the member of a structure. So it's really kind of the same. It's the reverse process of what we just did in class. You're looking at the assembly code, figure out what each register has, and then you try to map that to a construct in C, and go like, okay, I think this is what it is. This is what it is. And if I were to give you a question like that, where you have to reverse the whole process, I would also give you. Okay, let me go back to the beginning. I will give you these definitions so you know for sure that these are referring to offsets to members to a structure, and this is referring to the size of a structure. And then when we have stuff like I'm not going to trick you guys and use some really oddball labels. I would do something really kind of like this. So for the most part, you can always tell what are the local variables, how big each one is, and what is your parameter, just by looking at how the labels are defined. So you basically start with those things. And then other clues you can also use to figure out how to map back to the original C code is to look at the compares. Okay, so I'm just going to look for CMP. So CMP is a very good clue, not by itself, but by the conditional statements right after, the conditional branches after. Because if you see a JLI, that is basically telling you that you just compared signed values. Okay? If it's a JCI, then it is telling you that you just compared unsigned values. Now, if it's only a JCI, you would have no idea. Okay, JCI doesn't tell you about the signedness, nor whether it's an integer versus a pointer. JCI can be a pointer, but it can also just be an unsigned integer. You cannot differentiate just by using JCI. The only way you can tell whether you're dealing with a pointer or not is to see how you use that register. Are you using that register as an address of some kind? If so, it is a pointer. If not, it is not a pointer. If you add a displacement to that pointer to get to something else, and that offset is an offset of a member, then you're dealing with a pointer to a structure. So you're basically just reversing the whole process. Okay, given how some of the labels are defined, those would be your quote unquote, that would be the starting point to kind of unravel the code back to C code. So I'm not sure whether that helps or not. And then in terms of structures, control structures, there are only three main structures, and I only use two most of the time. One is a while loop, and one is a conditional statement. So in this case, whenever you see a label like this, line 134 in the middle of something, okay, that tells you that it is probably identifying a particular type of control structure. Even if the name doesn't have while or if or cond or something like that in it, you can still analyze it, okay? Because if it is a label where the JMPI is after the label itself, it is a loop. Okay, like in this case, while begin is defined here, but we reference the label all the way down here. So if the reference of a label is after the label definition, it is almost all the time, telling you that you have a loop structure. Now, once you have a loop structure, then you have to identify, but how do I get out of the loop? Typically, it has a label, right after the JMPI instruction that will tell you that identifies the exit point. So the J blah blah something out, to that end label is how you get out of the label. Okay, so the code from here all the way to the conditional branches that would get out of the loop, that would become the condition that you use to determine whether you should stay in the loop or whether you should get out of a loop. What if it is a conditional statement? So the conditional statement typically has a forward reference of a branch, of a conditional branch. So let me give you an example here. We do have one. So if one end is defined all the way here, but the reference is much earlier. So you can see this one is a forward reference because the reference or the jump to that label is all the way up here, like right here. So if you have a forward branch, where the JMPI is before the definition of the label, then then it's very likely that you have a conditional statement. So if you have a conditional statement, then the next question to ask is, where is the then branch? Where is the else branch? What is the condition? The condition is always before the branching, right? Because that's how you evaluate and decide whether you want to get to the then branch or go to the else branch. And if you the identifying the then versus the else branch is a little tricky because that is a polarity kind of thing. So most of the time, if it is a if then else, I would accept two different ways of interpreting the condition, because if you say if C then um, okay, you can reverse the whole thing. Okay, you can specify the condition and then specify then the then case and the else case, but you can also specify the negated condition and then you specify the else as if it is the then case, and then you specify the then as if it is the else case. So there are two ways to express a if then else type of control structure. In our case here, it's a one way. It's just a if then. There's no else in this case. So that's kind of how we reverse the process, when it comes to when you're given the assembly code and you have to reverse it back to the C code as much as possible. It's not always possible to reverse everything. If I don't give you any conditional branches like JC something or JL, JCI, JLI, then you would not be able to identify whether it is signed or unsigned. So in those cases, you can just, whether you tell me it's an int or uint, both will be accepted as correct answers. So that's pretty much it. I mean, it really is a different way to apply the knowledge that we have learned in this class. And no one in this class has any advantage, because I don't really privately tutor people, in the class content, so everybody really gets to the same content the same way. So if it's a hard test, it's going to be hard on everybody basically equally. All right, so I'm not I'm out of topics. I mean, the reality is I have been out of topic for like 2 weeks. I think some of you probably recognize it. Oh, Tack, you're just redoing, you're just you're just putting things into a box and shuffle it in a different way and call this a new product. That's actually how a company that I worked for before, that's basically how they came up with new products. Yeah, just put the same parts into the box, shuffle it, shake it a little bit, go like, oh, okay, now we got a new way of rearranging these things, and let's call that a new product. All right, I'm not seeing anything from the text channel. And it's still going. I'm just making sure it's not frozen, because sometimes that happens too. So if there are no specific things that you want me to talk about, I can stop the live stream, but I'll let you guys have a chance to maybe ask questions, or I'm still not seeing anything. I'm gonna start to do this, right? I'm gonna twiddle my thumbs like that. That's what happens when you're when you still have a regular hard drive. When the hard drive is seeking to another track, your 4 gigahertz CPU is doing this really, really fast when your hard drive is seeking. Oh, sure, absolutely. Well, thank you for your contribution for the tool. I like the interface of the tool. It's very simplistic. The reason why I did mine in Logisim is because I want people to be able to see and quote unquote touch and feel how the inside of a processor works. because otherwise it becomes a syntax thing, right? Because most people will look at LDCA, like in this case, and most people would just think, oh, parentheses means dereference. No, no, that is not the case. Okay, parentheses are here because I want to emphasize that A is being dereferenced. But the reason why it's dereferenced is not because syntactically we have parentheses around it. The reason why it is dereferenced is because of how the microcode is instructing various components of the processor. It connects register A to the address bus, and then it takes the data out of the RAM and use it to update register C. So that is the reason why I did everything in Logisim first. So everything else is and has been an afterthought. It's based on the Logisim defined structure first, and then all the other tools are basically just helper tools to get that portion to work in a way that's human friendly, more or less. And I have to emphasize more or less. Okay, so to address that last point in the text channel, I think trying to get the last homework assignment to work is probably a good idea. It can be very frustrating, okay? But when it's frustrating, you still have to do it one step at a time. People get frustrated because they look at something and it's like a gigantic task. It seems impossible. But when you approach it one step at a time and go like, okay, I know the program is working up to here. Okay, good. Working up to here, working up to here, working up to here, and not working here. Then don't focus on the rest of the program, okay? Oh, but we are only 5 instructions into the program, it's already not working. Well, that's okay. Doesn't matter, right? Because the first spot when it stops working is where you start your debugging. So you just, I mean, there's no way around it. You really just do it one step at a time. All right. Um, you guys talking about exam 2? I'm still working on it. Some of you are seeing, the exam being shared back to you, with the key interleaved with your answers. So it's a very lengthy process. Um, I was definitely planning to get it done a lot sooner, but then I got a class that I had to teach out of nowhere. This is also a kind of interesting situation. Not making an excuse, but I'm describing, the scenario. So there's this class is a mainframe class. The person who was supposed to teach, which is supposed to be a second 8-week class. So the person who was originally assigned to teach the class said no, he did not want to teach the class. So we hired a second person who got hired and who said, oh, I'm new to teaching. I cannot teach the class right away. If I can have a 4-week of a rolling start, so to get used to the system and kind of get used to everything, then I would be able to teach the second 4-week of the class. So I said, okay, since nobody else really can teach that class, I'll teach the first 4 weeks, which started at the beginning of April. So and during that time, I basically had to spend the end of Wednesday to the afternoon of Monday to prepare for the lecture on Monday and Wednesday. Okay, so I had no time, absolutely no time left to do anything else. So after 4 weeks, this person, was still kind of, just not really getting in. And then yesterday, that person told me that he decided not to teach the class. So two people basically, said, yeah, I would teach the class, and then say, no, I'm not going to teach the class. So now I have to teach the class until the end of May. So this is going to be a very interesting month for me. Yep. Yeah, those exams are long. They're not easy to grade because they're like a ton of variations. I already have the keys generated too, but to compare the key to the actual answers, that's still a manual process, unfortunately. Alrighty, cool. All right. What about the rest of you guys? Any questions? Because if there are no questions, I can stop the recording and then I can upload it. Yeah, well, okay, so there's putting in the work, and there's also in this class, putting in the work is really about understanding. Because it's open book, open notes, basically open Google, right? I mean, um, so it really boils down to the understanding of the concepts and commenting the program, finishing up this program and comment everything is really important. Now, some of you may say, but we never really got, the what is the correct comment. Well, that's not entirely true because as I was working on this program, I was actually talking to quote unquote myself the entire time. So that really is the comment. Now, I would be more than happy to answer specific questions. Okay, so if somebody were to try to comment this program up to a certain point and go like, I'm not really sure what is in this register. I think it is like this, but I'm not 100% sure. I'll be more than happy to look at that and evaluate and then give feedback to that person. Now, on the other hand, if somebody asks me, do you have like, a fully commented program for this entire thing and give it to me? I go like, probably not, because I really want you guys to do most of the work because it's doing the work that helps you understand the material. If I give you everything, I think some people would quote unquote study and study hard by trying to memorize everything, and that is going to be this is going to be counterproductive, because once I change the pattern, the pattern doesn't match what those people have memorized, then everything falls apart, right? Because those people are relying on the pattern to repeat, which may not be the case. So I think it is really important for people to break it down to very small pieces and understand what each small piece is doing, and relate what is in the register to concepts in the C program. That really is the key. Is what is the value in this register right now, and how does that relate to the concepts in the C program, and make as much association as possible. That is the key. All right. So I think I have been repeating myself for a while now, like a broken record. Um, so I really cannot think of anything new to say, and that's why I've been waiting for questions. But hopefully not the kind of question like, can you just repeat what you said in the past half hour or so? All right. Well, I'm not seeing any new questions, so I'm gonna end the live stream and then upload the video to YouTube as quote unquote part two, of this lecture. But it doesn't mean that I'm gonna go away and not respond to text messages. So you can still put text messages up to new trace log. Cool. Man, that was fast. Oh, nice. Okay, let me download it. I'm gonna guess this one is correct, but I'm gonna take a look. All right, so trace.txt. I'm still recording, by the way. Oh, I have one open already. Let me go back to that one then. There we go. All right. So going to the end, we got to the halt instruction. Yay. Um, it's it's only less than 1,000 lines, and that's because Jonathan's trace is more compact. It doesn't have all the empty lines that I have. because mine is working off of Logisim's log file, which generates a new line when one thing changes. And the execution of one instruction can cause multiple changes, and that's why I got a lot of empty lines in between. So we are storing 4 into location FF. That's good, So that means, I think this trace is correct. So now you have two ways of looking at the program that we examined today. Jonathan's tool as of now is correct. I'm not sure where you can get it or the updated version of it. Okay, and Jonathan probably has posted in the general channel of the update. So you can use that tool. You can use the trace analyzer, which is kind of clunky, but it has been around for a longer time. So it's up to you to choose which one you want to use. Same thing for the assembler. Jonathan's tool is combining the assembler, the simulator, and also the trace analyzer into one single product. Very nice. Okay, one stop, right? One stop shopping. Mine is kind of like, everything is broken up into small, tiny little pieces. Um, and you have to use Google Sheet and stuff like that. If you want the offline experience, Jonathan's tool is completely offline. So that means you don't need to be online to use that tool. Mine is based on Google Sheet. You cannot use Excel or LibreOffice to use the assembler, so you're kind of stuck. You have to be connected online and use Google, to use those tools. So it's up to you guys, however you want to do it. But I can tell you that the bug is fixed, and the trace is now consistent with the other one. So that's cool. Yay. Okay, so that's good. Um, Other than that, I am out of topics. So I'm gonna stop the live stream. Oh, here comes another message. Let me wait for that one. Oh, well, thank you for Jonathan's help. Anyway, that program is his baby. I'm just reading the text. All right. Oh, okay. So it's a co-development. Okay. Cool. Cool. This is great. This is actually good experience too. When you apply for jobs, you can actually quote experiences like this, because being able to work with other people and get a product developed, that sort of stuff, that's good experience. All right, cool. I'm gonna stop the live stream, upload it to YouTube, and then I'll just be watching the text channel traffic, um, and try to answer questions when you guys have questions. Alrighty, I'll see most of you next Tuesday, but I still have office hours. I'm gonna keep the same office hour every day, so it's from 11 a.m. to noon time. If you cannot make it to that time, just kind of ping me and let me know what time you want to meet, or text or voice chat online. Um, Fairly flexible in terms of my time, but I'm gonna make that time frame my quote unquote office hour every day. All right, cool. I'm gonna stop live streaming now.